So, hi everyone. Thank you a lot for joining us today. I see there is already a lot of activity in the chat. It's very exciting to see people joining us from so many different places: the US, Norway, Idaho, Morocco, India, Paris, Montreal. So, looking forward to all of your questions. As you could have seen already, we've been running a poll whether or not you have integrated Claude into your security workflows. And I think we'll reveal the results at the end of Geet's presentation. So today with us, two speakers. First, Geet Pradhan, who is a senior security engineer. So I've been known for already quite some time. He's built security programs from kind of 0 to 1 in very high growth organizations. He has deep expertise in DevSecOps, product security, security engineering, detection and response. And he's also a frequent speaker. So I have a lot of faith in him for this webinar. And also Tristan Calosa, CEO of Escape. So Escape is a fancy security engineering platform. I'll let Tristan also present you a little bit more what we are doing. Tristan started as a machine learning researcher at UC Berkeley and kind of been motivated by first-hand experience in hacking and API security hacking. He's become an expert in API security, and then he's been helping security engineers and developers worldwide building a secure application, also a frequent speaker at different cybersecurity conferences. And today he's going to also present to you Escape and Claude integration that we've been building. And just to answer your Sonia questions, Sriram, the session is being recorded. No worries, the replay will be available shortly afterwards on the same platform, so you'll be able to rewatch the most interesting fragments of the presentation. And without further ado, I'll give you, Geet, the stage. You ready?
Yeah, let's do it. Thank you for that great introduction. Yeah, thanks for having me, guys. I'm going to go ahead and share my screen because I've prepared some slides for this webinar. So Tristan, Alexandra, I guess everyone in the chat, let me know when you can see this. Can you guys see something here? I don't think I can see the chat. So maybe Tristan, you say yes or no if you're good.
Yes, that's good.
Okay, awesome. So cool. So today I am going to be talking about the fact that AI, Claude, Codex, whatever you want to call it, is actually pretty good at security engineering. So a little bit about myself. Alexandra gave a brief intro, but yeah, I am basically just a security person. I've been doing security for a while, and I've been recently playing around with, Claude, AI in general, when I found out that it's probably going to take my job. Turns out it is really good at doing my job. So I decided, hey, why not just work with it and try to see how I can fit it into my kind of daily things that I do as an engineer, right? So let's dive in. So what we're covering today, I want to talk about kind of what is security engineering, essentially, some of the problems we see, and a couple of examples in my daily, weekly, what I do, and where Claude or ChatGPT or any of these kind of tools can really help us. So when you're like an early engineer in a security team, maybe your team is team of one, team of two, there's a lot that happens, right? Whereas always maybe one person and you have to really cover every domain, right? When, let's say you're in an e-commerce platform, or let's say you're working for an AI product company, there's still a lot of expertise that you need when you're the only security person in your team. You don't always have that. Nobody actually has all the experience for everything you do. And the gaps essentially exist when you run out of time, right? A lot of tools are really expensive. I've named a few which I've played around with before in the past. They are quite costly. You don't always have the money for a new tool or a new shiny toy. And there's always something happening, right? Like you're always reactive, you're always firefighting. in my opinion, all this is not a knowledge problem or a work ethic problem. It just doesn't work. The mathematics just doesn't work when it's just one person or two people really dealing with the expectation of a whole team, right? Now, what the job essentially normally covers, according to me, now security engineering is really different based on who you ask. But I think there's three aspects to it, right? There's the proactive security aspect that everyone knows, which is, hey, we have our threat models, we have our security reviews, we have designs, etc. We have the reactive stuff, which is, detection response, any sort of incident that comes into it. You have to investigate, you have to contain, a lot of the operational side. There's also the actual engineering work, right? Which is building those systems that catch things automatically, or doing something which you can build a pipeline for, let's say, vulnerability management or actual engineering work so that you can assist both the proactive and the reactive sides. Now, where does Claude fit in? Now, in my opinion, again, I'm using Claude as an example here. Claude acts as a force multiplier, right? Don't think about it as AI is doing security. Just genuinely think about it as having a always on, always present advisor who you can ask questions to when you don't know the answer, right? I find myself asking questions such as, hey, even calculator questions, which is quite embarrassing sometimes, but it never gets tired. It's always on if you don't have token limits, right? And it's honestly just knows everything about everything, right? Now, to the points that I mentioned previously, essentially this one engineer, or this Claude engineer, or Claudager, whatever you want to call it, covers all the gaps that maybe you don't have expertise in, right? All the domain knowledge that you want, let's say the LLM top 10, OAuth top 10, SOC 2 controls, CRA, EU AI Act, whatever you want. If you really don't know what's happening, you can just ask this particular advisor whatever you want, right? It also reasons. It's not just like a pattern matching of, hey, is this equal to this? It will try to find something and insights based on what the problem is that you're defining. However, it's also really good at getting your standard security outputs, right? Like your threat models, your rules. It's really good at just spitting out output or even reviewing output. Now, in my experience, there's a few areas, right, that this really plays out in. Like, I'm going to touch on those three. I'm going to touch on a little bit on threat modeling and reviews. I'm going to touch on detection engineering, and I'm going to touch a little bit on incident response. There's also a really cool blog that I found that I'll share with you. It's in the slides, so I'll share the slides, maybe, Alexandra. And it really talks about why security engineers who ignore Claude code will be obsolete by 2027. Now, I don't think that harsh about it. However, I have been on the other side of like thinking that AI is going to take my job. I have now turned and been like, hey, AI is really going to make me do my job better, right? So just a quick TLDR, right, on some of these models. I'm sure there's more, and there's more experts out there who know this more than me. But essentially, there's different models for doing different tasks, right? Haiku, Sonnet, Opus. Haiku is traditionally a little cheaper. It's really good when you don't have to worry. You want to be cognizant of cost. Really good for a lot of that stuff. Sonnet is essentially your everyday workhorse. Kind of does everything a little bit better, in my opinion, than Haiku, but a little cheaper than Opus. And Opus is the best. Best at reasoning, best at judgment, best at most things, best at also taking money from your wallet. Right? It is quite a bit more expensive. These are just these ranges that I found on the internet. I'm sure there's loads of resources that you can go and hang out and read about this. I'm not the expert at which model does what. However, in the examples that I have, I am going to touch a little bit about what I did when I was doing this and what models I recommend for. So let's dive in. Now, threat modeling or proactive security, one of the things that I have done in my previous roles, or even the products that I'm developing myself, any apps that I have, anything at all, right? I try to do a little bit of threat modeling, right? Looking at all the fun different phases of RFCs, PRDs, ERDs. And I also built a really cool product, which I'm going to talk about, and what I did with these bunch of agents that I'm going to talk about. So one of the really cool things that I have done with Claude is essentially have an army of agents, right? Now, what does that mean? Essentially, what I've done is I've created a persona or an agentic persona for different types of domain knowledge. So I also have a skill which works locally on my machine, which when I say, hey, /security review, it will read all the artifacts that I give it. Maybe it's the code, maybe it's documents, maybe it's just a whiteboard drawing that I have that I thought of one random day. It will analyze that from whatever information that you feed to it, and it will take it and it will kind of break it up into different lenses. So the architecture of this, what I'm going to talk about, is essentially it's your kind of meta level triage agent, which is on Opus, right? It will read all the artifacts and it will try to reason on what exactly this is, right? Is it a feature? Is it a huge product launch? Is it just some random scribbles? And it will then try to analyze what are the different phases or different domain expertise that need to be called during the review, right? Let's say it's a detection rule or something to do with a SecOps particular pipeline, right? I don't think it always needs to call a product or an AppSec agent, right? Vice versa, if it's a DevSecOps related change, it doesn't need to always call a SecOps agent. So the security triage will essentially reason and call the sub-level agents, as I like to call it. Then these agents get dispatched parallel in a parallel manner. They perform their reviews based on the prompts that I've provided them. Once that's done, the security lead, which is like another agent that I've created, which essentially kind of comes in and takes all the findings from them, it will try to gather them up and will deliver a report. Now, this is not something which is new, right? This is how normal work intake happens, even without agents. Normally, and it differs from company to company, but there's always, maybe a PM, maybe a manager who will take in the work and call their security team saying, hey, look, someone from the SecOps team, I need someone to review this RFC that someone has. All these findings are again given away to maybe a principal engineer or again the manager for them to essentially review and consolidate everything. So the point I'm trying to make here is I'm trying to replicate what a multi-human team would be through agents. Now, there are nuances to this and it doesn't always work this way, but this is kind of the architecture that I have been creating. Now, what are the benefits of this, right? You don't need to do security review yourselves. Normally, when you would do this yourselves, even with the domain knowledge that you may or may not have, you would Google, you would Stack Overflow in a previous way, or you'd even ask Claude these questions. It's sequential and happens one domain at a time. You would look at each document at a time, and it does take a lot of time, right? In this case, you would orchestrate that team. Everything runs in parallel. You have all the domains, every review all the time. You can also have this at any phase because essentially you have to just point the documentation or point the source material you have, and it will review it in a manner. Now, I am going to hover over. I thought to myself if I should do a live demo. Unfortunately, yesterday when I tried to practice doing a live demo, my Claude tokens ran out. So what I'm going to do is I'm going to show what I have done previously. So there are a bunch of agents that you can see here, right, that have some sort of context around them. They're all called by different commands. So in this case, the security review command is the one we spoke of. Essentially what this does is that it reads all the artifacts that you give it to it. It'll triage them, and then essentially it will call all the different alerts, the agents that you need. So in this case, map these names and call these domain agents. Let's take GRC security expert as an example. There's a prompt that I've come up with. Again, I asked Claude to help me come up with this. Essentially what it does that it's an expert at GDPR, expert at GRC, and it will analyze whatever source material that you have based on a GRC lens. Similarly, I have the same for network security, I have the same for platform security. And if you remember on the workflow that I have, it all comes back into the security lead agent, which is right over here, right? The security lead agent's job is to essentially collect everything from these agents and synthesize and get all these different things that maybe it's a redundancy check, maybe it's false positive, maybe it's severity recalibration, essentially serve as that a second round of triage, if you will. Now, I ran this review and I got something on a real life example. Now, what is this example? Nothing crazy. Essentially, me and my partner were trying to figure out a way of how we, text each other and realize, hey, we miss out on deadlines, we miss out on a lot of things. So we created a WhatsApp bot called Pacey. Again, it's just something which is a sample product that we have. I ran this on some of the documentation that we have, and I found some really cool gaps, right? Something around AI security, because there was potential prompt injections. There was something about DevSecOps and SecOps, and each of the agents that I ran, I think I ran 5 agents. There were around 9 documents, and it took around three-ish minutes, right? Great. Now, what the findings are in this case are not really that important, because it will differ based on kind of what you're using it at. But what is really cool is when I ran these findings straight away, there were over 96 individual findings, right? Now, when I had a deduplication, which is the security lead deduplication, this is why that architecture matters, it really went down. And it came to around 44, right? Because there may have been some findings that maybe the DevSecOps agent also found and the SecOps agent found. So coming back to this, if I go here, all the outputs, let's say the SecOps agent, right? All the outputs that come out are in different findings, right? In this case, it's based on mapping to sec 001, 002, whatever the name of the agent is. And it essentially will tell me, hey, this is the severity of the finding. What is it? What are mitigations? Exactly how a reviewer would do it. Now, people have asked me this. I was having a conversation with Alexander as well. How do you know which models to use for what? Now, this is really interesting. And I think this is where I did a mini sort of experiment with this particular product that I have. I think that Opus is really good for reasoning and more open-ended things that are not as well documented. They're still experimental. People are still learning about new things that are happening in that industry, for example. So what I have done is the security lead, which is the triage and the lead, is using Opus, and so is the AI security, right? So the security lead, why? Is because there's a lot of different findings that happen. There's a lot of agents that are talking and feed all that information to the security lead agent, right? Now, this agent really needs to be really good at reasoning, what is good, what is bad, what is acceptable finding, what is not, what is deduplication, exactly what we had over here. And the agent needs to do a lot of these steps. So from doing this analysis on, having multiple different agents and also running everything on Opus, what I found is that Opus is pretty good for this. Now, Sonnet is also really good for a lot of known patterns, right? With app security, OWASP top 10, they're known patterns. There are lots of things that still are unknown in this case, right? But there's a relatively fixed answer space. Similarly with SecOps, detection absence, things like that, pipeline and DevSecOps. When I ran all of these in all Opus versus I ran it in this kind of smart agent review, it's a pretty cool experiment. So in terms of cost, the all Opus run, so all the agents on a 5 agent and a 10 agent, because there's kind of 2 different agentic workflows. Opus was nearly 2x, I think just above 2x actually, just around 2x of the cost per run for the whole agentic workflow. The smart assignment is the one that I spoke about, which is like security lead and AI security on Opus and everything else on Sonnet. It was half. What is really interesting is that the findings were a little different, right? The total findings were higher on Opus with a little bit less critical. Maybe the reasoning was higher. And in the smart assessment, there were less total findings, but a little bit more critical. So it is worth noting, right, that Opus is a much better model for most of this work, right? When I looked at the actual findings, right, the 7 or 8 finding gap is primarily between medium and low. There were a couple of findings which were kind of, severity was up and down here. Um, but Opus, it was just better in getting the accuracy, in my opinion. However, Opus does use more tokens, right? And it does run slower, and it does need a little bit of hand holding or scaffolding to get the most out of it, because Opus is more reasoning and it thinks it can go in different direction. So based on the experiment that we did, this is kind of what we came up with, something that works. I also have a comparison report on all the finding counts and things that Sonnet missed. In my example, weirdly enough, Sonnet missed most of, like, the highest missed were secops, which is interesting. I haven't dug into it myself as to why or why not, but it's really cool. It's really cool, right? As for the model rationale, right? Again, I had Claude help me in creating all of this. So Anthropic, if you're listening, this is a sales pitch. Yeah. Moving to the next one, which is, now we've spoken about proactive stuff, right? We've come up with a few agents here and there. They've given them some sort of identity in the sense of, like, hey, look, you are specifically an AI agent for AI security versus GRC security. We are kicking them off with a command, right, which does it when we give them the source documentation. And we've replicated what an engineer would do when they're actually reviewing something on the proactive side. Now, on the engineering side, something that I'm really passionate about, and is detection engineering in general, right? What I think Claude has been a game changer for me to scale my own detection engineering platforms and my own pipelines is it's really good at doing a lot of the stuff I am really bad at. So something like writing rules, which works, something like writing those validators that you need to make sure the scaffolding, as I call it, and things like coverage reports, right? So let's talk about that. Now, the workflow here that I want to describe is, again, I get Claude to write the rule for me. All I have to do is say, hey, look, Claude, I want a detection rule for, alert me every time there's a public S3 bucket, or a S3 bucket turns public, or something like that. It really does a good job, right? It will create it based on kind of the context that you give the agent. Maybe it's Sigma format, maybe it's like Splunk query, maybe it's KQL, Sentinel queries, whatever you want, whatever your SIEM is or whatever your platform is. You just have to kind of tune that agent a little bit and say, hey, write the first draft. And you then can have kind of validation rules that run against it on the CI, which you can get Claude to generate. I don't think Claude needs to be called for every single validate schema.py in this case, because essentially it's just validating a schema, right? Which should just be a Python script. You don't need to waste your tokens on that. However, Claude can help you write that validator. The third one is the efficacy check, right? Now, efficacy check, it previously has been a script. In this case, what you can do is you can get Claude to help you rate its own work, essentially. And the fourth one would be a coverage report, right? Which I'll talk about in a second. Now, Claude writes the detection rules. Something as simple to Claude would be like, hey, Claude, write a Sigma rule to detect a prompt injection attempt in an LLM pipeline, right? You give it the log source, you give it a bunch of different, fun informational things that you need in your own pipeline, and it will write it. Now, I am very scared of the demo gods, yeah. So I don't want to open up Claude and do it, because I'm pretty sure it's going to break at some point. So what I've done is I have already ran that for us. And I've created these commands, which is rule write and rule review, right? So the rule write essentially calls my rule writer agent, which is in detection engineering. What this rule writer does is it looks through the structure of your detection rules folders, right? It will determine the category, create a UUID, and write the rule for you based on some of the fields that you're giving it. And it does a pretty good job, right? It does a efficacy check initially. However, it's not always perfect, right? And it just writes the rule. Now it's really good at writing this rule, right? I can show you a couple of examples that I pulled together right before my Claude tokens ran out. Let's see which one, secrets. Okay, cool. So it wrote this entirely, right? I just said, hey, Claude, write a rule for credentials that are potentially exfilled. And it did it, right? Obviously, you have to tune it a little bit. It's not perfect. But the end goal is, and this is kind of my North Star, is you should be able to one-shot a detection rule, which is really cool. And it does it according to your Sigma rules or whatever formats you have. I would say here is always check the work, right? Add some sort of validators. In this case, I have a Python script which checks what the required fields are, which essentially adds as just one more check so that I trust my AI agent, but I don't really trust my AI agent. I'm kind of scared of Skynet, Cool. Now, the schema validator, once you have Claude write the rule, the schema validator would catch it. So in this case, hey, your rule is missing a field, your rule is missing a tag, your rule is missing author, things like that. Now, once everything's passed, great. You can move on to the next one. Now, this is, I think, one of the best things in a detection pipeline that Claude does. Claude is very good at reviewing itself, right? You just have to do it right. Now, you can write a line saying, hey, make sure you review your work before actually doing it. However, that doesn't stick in my experience. So what I have done is I have created another agent which essentially reviews the work, right? It is like a really strict teacher, reviews the work, runs the efficacy check, applies some sort of peer review, right? Applies some correctness, things like threshold, time frame, false positive, accuracy for what sort of rule that is. And it does a really good job here of checking for the efficacy. Now, plus points if you have a SIM, like, a SIM which has MCP connections, a SIM which you can get a token or has a CLI. Maybe you can test something like Claude checking this rule fits. Maybe you can have a pretty interesting agent of pulling out some sample logs, seeing if it works against these logs. There's a lot you can do, right? But at the base level, assuming your SIM does not have any of these cool features, you can go ahead and just have it review its work. I would suggest have a separate agent to review its work. If you have a Codex and a Claude, maybe you can experiment Codex writing the rule, Claude reviewing it. Claude writing the rule, Codex reviewing it. At the crux of it, I think what you need to do is make sure have Claude or any of these agents review their own work. They're really good at it, right? Now, step 4. This is a really, really because I was building Pasty as well. Can Claude be a good enough coverage scanner for me, right? Now, what is a coverage scanner? In this case, what I'm looking at is, hey, MITRE ATT&CK framework, everyone knows of that. Is my detection rule library really good? Do I need anything? Do I have gaps, right? Now, previously, this was done with scripts. They would you'd just be like, hey, every rule has a tag to it, like privilege escalation, like MITRE tag. It would just create a matrix, and some sims already do this. It'll create a matrix and just see if the rule has, if you have a rule that matches that. What I think Opus does really well at here is it will really, it will do, a Sonnet in this case, not Opus, is that it scans all your rules. It will, you'll give it some context in this case, like, hey, this is my tech stack. Here's some realistic attack scenarios, what this stack does not have. Just giving it some sort of guidance. And then if you run a coverage reporter as well as you essentially add a few contextual things like, hey, look through it entirely, and it does a pretty good job. It does a really good job at going through your entire tech are, right? In this factors that were covered, things that were not covered, and it gave me a really cool is not sorry my connection is unstable. Is everyone getting an unstable connection as well? Is it okay if I remove my camera, Alexandra?
Yes, there were some people who were saying that it cut out sometimes, and I could see it on my side as well.
Okay. Well, sorry everyone. I will switch off my camera and hope for the best. Okay. So if it continues, please tell me. I'll try to find another solution around this, but this should be fine now. Now, I do want to say here, the benefit of doing this versus doing it what previously used to happen, right? Previously, it used to be, hey, I write the rules. Maybe you have a QA team, maybe you have a PR that someone else has to review, and it's difficult, right? It's not easy to write rules. You have to really think about it. You have to go um, look at different resources to find those rules, maybe detection libraries, right? Um, and all the quality and the validators, although they exist, they're dependent on code that's written by someone. They're dependent on reviews. Coverage has always been bad, right? What Claude does, it essentially removes the objectivity from this and handles a lot of it itself, right? It'll create those drafts that I mentioned of the rules in seconds. It catches, coverage is pretty good. The floor in this case is significantly improved, right? Every rule has some basic standard based on what you give it. Now, again, going on to which Claude for which detection task. Now, in my opinion, Sonnet is really good for things which are scriptable, right? The detection rule writer, you're already giving it a lot of context. Use Sonnet for that, right? YAML is pretty standard. MITRE tags are pretty standard. Sonnet can be used for that. Reviewing the rule can be something which Opus does for you, right? Because Opus needs to know if, hey, is it a good rule, right? Does it mean that it needs some sort of operational judgment on, is it going to be very loud? Is it going to be very quiet? Is it really going to work in your environment? Maybe you give that to Opus. The coverage scanner, I think it's interesting because it can be either way. So either Sonnet or Opus. Now I know we're cognizant of time, so I'm going to move on to the reactive security side. Now this is really interesting, right? What Claude can be really good at is investigation. If you can feed it a log or some sort of log and say, hey, make sense of this, right? It does a pretty good job at coming up with something which will help you dig into it further, right? So in this case, what I've done is I have, again, a few more agents. So I have let me see. So I have a triage command, which will then call my investigation agents. Now, my investigation agents, I have a couple. I have an analyst, I have a SIEM investigator, and an alert passer. Now, what happens is, phase one, the alert passer agent will just pass the agent and, make sense of it, right? The SIEM investigator agent will essentially query what else you have. Maybe it has pivot queries. Maybe you have a CLI or some sort of token onto your SIEM. It'll dig into that. And the third one is just getting some sense out of what is happening, right? So triage verdict, essentially for the IR analyst agent will find that. So coming back, it triggers based on, something you say. Maybe it's like a -triage command that as I showed you. It could also be a webhook or an automated triage. There's multiple ways of running that. Then it spawns these multiple agents, which is the analyst, the SIEM investigator, and the L1, as you call it. Ideally, if your SIEM has an MCP, or if it has a CLI, or if you can give it a token to kind of dig around, that would be great, because that's the best use of Claude, of like taking that going back to your system and trying to find and make some sense out of it, and it can give you a verdict. So again, it's like a small scenario. I've played around with a couple of sims on this. The sim that I'm really impressed with is a sim called Run Reveal. What it really does is, it has its own MCP, it exposes it, so you can really use that as well if you're playing around with it. But you can also just plug in your kind of Claude, OpenAI, and build agents off of there, the ones that I told you about. So, that's a really cool one if you want to play around with it yourself. Again, not sponsored. I just think it's a great product. So without Claude, if this comes up, you open the sim, you will pivot around some of these log sources. You try to find what's happening. You run a few queries here and there. You write a ticket. Okay. It'll take you some time. It'll take you maybe 30, 60, 90 minutes, whatever the time frame is. With Claude, if you just run that triage command on this particular log that comes in, or these 4 logs that come in, or as a complex query, it will take approximately 45 seconds to a minute, maybe less, maybe more, to actually make sense of what you're doing, right? It will tell you if it's a potential false positive, and it can also give you like an indication, at least a direction of what you need to do. So in this case, the Splunk MCP server and GitHub MCP server is just an example, right? What you need to do is you go to your settings.json on Claude, and you kind of plug in the MCP. Obviously, you can figure out how to auth. You can have a token, or you can have some other way based on what your company or your personal project wants. However, the triage.md, the one that I showed you, is the same thing. Give the alert ID a context, which is -triage, and call these 3-4 agents to essentially do something for you and do that work for you in parallel, right? Now, coming back to my incident response ones, these agents will run, and the analyst will essentially give you that verdict, right? And the definition of the verdict and the severities. So what this comes out to be would be a report that you can make sense of. So this is an example, right? The triage analysis, agent 1 kind of got these 4 things that I spoke to you about in the last slide. Agent 1 also kind of reconstructed it. Agent 2 went back into the sim and kind of tried to see what it could find, right? Maybe last 10 days, last 20 days, see if it's actually happening or not. And then agent 3 kind of worked with them, added some context, and came to a decision of saying, hey, this is normal. This is something that no real indicators of compromise. It just seems like someone created a new repo, and this is just your standard repo initialization in your company, right? So great, a big green false positives, and you can close alerts. In this case, some stats, 4 tool calls, 8, 9 evidence items that you had, and it took about 45 seconds. Now, this is just a sample, right? You can use this, you can kind of play around with these agents as well and see what works for you. But it has worked for me. Now, and again, as I said, you just run one command. It doesn't take too much time. And essentially, the North Star that I think about for incident response in general is whatever you can do to save time while actually running the incident or running a response task, that is great in my books. Now, which Claude for which task? I think this would have probably been expected, right? The one that I would use Opus for is the one that reasons, which is the analyst, which is the 3rd step. The alert parser and the investigator agents, I think they're already given some sort of input, right? They're given the alert, they're given the connection to the SIM and kind of the queries. They may not need Opus. However, phase 3 is the one that really makes the judgment call, makes the decision, and really needs the bulk of the processing power, right? So an argument can be made to have all 3 in Opus. If you really want to be cognizant of cost and actually decide which token you want, which model you want and the token cost, this is what I think would work. I think that is it for me. I'm going to put my face back on so people can see how tired I am of talking. Yeah, I guess any questions? Are we taking questions, or do we want to take that at the end?
I think we'll take some questions at the end because we actually have a lot of questions. I think there are more than 20 questions for you.
Okay, great. I'll try to answer that.
The one that you can already kind of get prepared of is the same one like I asked you before this week. Is the GitHub repo going to be available?
Um,
That's the one
that's a
that
great
people
question.
the
That's a great
most.
question. I will work on it. I will maybe Tristan, Alexandra, I can chat with you guys and you can share it around as well. Um, it is currently private, and some of these agents may have some like Geet specific stuff on them, so I'll have to just clean them up a little bit. But yeah, sure, I will. I will get those out so you guys can start using these agents. And any feedback on the agents and things that you are doing better with these agents, please tell me. You know, we're all here to give Anthropic and OpenAI our money anyway, so might as well do it together, right?
Yeah,
Yeah,
and
I'll
you
do
have
that.
the button to connect with you on LinkedIn.
Yeah,
On so
awesome.
thank
Yeah, add me on
you.
LinkedIn. Happy to chat, and I will now be quiet.
Thank you, Geet. Don't forget to remove any secrets from the seal files before committing publicly. Great. So let's after the first presentation that was made by Git on the topic of really detection engineering and more like using AI models for specific engineering tasks inside of like code or inside of like precise issues analysis. I will tackle another topic, or we'll move on to another topic, which is using AI model as assistance for enterprise scale analysis of data or for larger analysis rather than detailed analysis. So I'll share my screen specifically on the topic of offensive security. Okay. Okay, hello everyone. I'm Tristan Kalos. I'm the co-founder and CEO of Escape. As Alexandra said earlier, I'm formerly an AI researcher at UC Berkeley, and then I became passionate for AI for security automation, and especially AI for security automation at a scale that is way larger than what context windows can handle, and where the frequency of updates and evolution of the environment is very high. So it's a challenge of large-scale usage of AI for security. So first, let's take a look at what AI gets right when it comes to security and what it doesn't yet. As we saw during the last presentation, AI is extremely good at research and reasoning. So analysis of findings or code bases, reasoning on existing findings or reasoning for finding new vulnerabilities, explaining security data or context, and really doing a deep analysis of existing data, manipulating data with a lot of intelligence in the data handling. What is struggled with, on the other hand, is scale and discipline. It struggles with scale, repeatability, false positive discipline, and process. And those struggles are linked to different limitations of AI models. So for instance, with scale, the token usage is exploding when you are manipulating the data from thousands of assets, right? It works very well for a single code base. It works very well for finding specific things, but where you have a continuous analysis of thousands of data points, then the cost is prohibitive. The repeatability is also an issue. Same prompt can return different results across runs. So it's not a problem if there is a human in the loop, if we're analyzing things. But if we have automation running at scale on thousands of different data points, then it can create a lot of noise in the reporting. And also false positive discipline. So we observe that models tend to exaggerate severity. I see a comment about, is it too small for you guys? Better like this? All right. And so the model tend to exaggerate severity, which means that at some point there is still a human review in the loop. Yes.
Yes, maybe Tristan, you can go in a slideshow mode and like hide the conscious chat because no worries, I'll handle.
Okay. You guys are seeing it. All right. So I can do that. All right. There we go. Do you still see the full screen with the presentation?
Now it's great.
Okay, excellent. And so finally, it favors ad hoc experiments and ad hoc processes instead of standardized guidelines, which can especially becomes a problem when you have distributed engineering teams and centralized security teams, and you need to enforce the same controls over different type of engineering environments. So this is a double-edged sword paradox of AI in cybersecurity, because the tools at our disposal today are more powerful than ever, yet security teams have never felt as outnumbered by the amount of code that is produced, by the pace of evolution of the technical stack, by the new type of attacks that are being created. So it's a kind of a strange feeling. And this is what we are interested into researching and helping to solve at Escape. So the question that we are trying to answer is, how can security team leverage AI to multiply their outcome exponentially without scaling headcount or burning billions of tokens? And as Geet said, we love spending money with Anthropic and OpenAI, but it can also lead to prohibitive costs. So we need to find the right balance of security, human in the loop, and usage of AI and AI spending. So all principles at Escape, and we have come with those principles for developing solutions for that. All principles is that offensive security is becoming an engineering discipline. Rather than a point-in-time assessment, is becoming embedded into the engineering process, is becoming more continuous, it's becoming more the frontier between offensive security and security engineering is becoming more blurry. The second thing is AI agents and custom scripts are not second-class citizens anymore. They are like first-class citizens. And so any tooling for offensive security, any tooling for security engineering needs to give access to AI agents and to custom scripts, the same powerful feature set as human has access to. So they are also users, like humans, of the security tooling, and we need to be prepared for that. And the third principle is invest heavily in harness engineering. So invest in all the engineering that goes around the model to mitigate the limitations of AI. The thing is, it's not really the model that counts, because the models are getting better, but everyone has access to the same models, including the attackers. It's using the models 1,000 times better than attackers. It's using the models better to stay ahead and have the right level of security. So in this context, a little bit of info about Escape, so you have context of what we will do today. So Escape is an offensive security engineering platform. So we provide tooling for humans, security teams, and AI agents to perform automated discovery to remediation. And it's been built, of course, with AI agents in mind. We have three main class of products: AI pen testing to perform a full automated security review of web applications; attack surface management to discover exposed applications and web apps continuously across all the networks, internal and external; and business logic aware DAST for continuous security testing at a cost-efficient level inside of the CI/CD. So the thing with Escape is that it's built for harness engineering and AI agents. So we build the full platform. Of course, it's accessible by humans. You have access to all the data, but it also exposes an MCP server that has complete feature set access, a public API for programmatic access, and a full class CLI tool for running scans locally, for shipping offensive security into scripts, for shipping offensive security into the CI/CD, and so on and so forth. So we will cover 3 use cases today as examples, and classic examples of what you can do by using AI models and, for instance, Claude Code or Claude with the Escape platform to perform various security operations very easily and at scale. So I will use an existing tenant of Escape. You can see that this is a real data set from Escape, from my demo tenant. And you can see that I have like more than 300 assets that are being actively and continuously discovered and evaluated by Escape. You can see that we evaluate if they are accessible from external networks, if there are vulnerabilities on it, what's the status. We have web applications, we have REST APIs. So this is a demo discovery of the environment that Escape exposes on the internet. And we'll work with this environment. You can see that Escape provides a view of all the issues that are accessible in this environment. So we have various security issues that have been put there for the demo. And we have also like the tooling to perform the pen testing, so I can run a new pen test manually on any web application and have our fleet of AI agents performing advanced pen tests from the UI. But today the UI is not what is interesting for us. So what is interesting is 3 use cases that we can run, not from the UI, but by AI agents that will interact with the platform in full autonomy in order to perform various security tasks. And I will cover 3 use cases, which are pen tests, remediations, and control. So let's start with it. The first use case is a use case for application security, folks. So it's a prompt that will run on a vulnerable application created by Escape called Duckstore. And it's a command to tell Escape to perform a full-scale pen test on a specific application. Put it very, very simply. So for this demo, we'll use Duckstore, which is a vulnerable application created by Escape. So it has a lot of vulnerabilities hiding in this app. And we can use it as a test for or pen testing system. So it's very simple to start actually a pen test with Escape and an AI model. We can just use the Escape CLI or the Escape MCP to perform this. So here I will use this command here in my Claude code, but it works also with the Claude online. And we will use, the Duckstore URL here. All right. And we will use those test credentials that I created before the presentation. So very simply, what we are doing here is we are just giving Escape a URL, a username, and a password. And we are telling the Claude Code integration to set up the scan for us, to set up the pen test for us. And then the AI agents from Escape will take it from there and perform a full security assessment of this application. And this is the only thing that we have to do. So it will go on the website. So like what will happen here is that Claude will give this data, of course, to Escape. But then what will happen is that Escape will visit this website, identify where to log in, enter the credentials, and then launch a fleet of AI agents to perform the full security assessment and give us back the result. Right? So it's very, very straightforward to set up. Now we'll let it run. And in the meantime, we can take a look at the second use case that I wanted to show. So this use case is more for software engineers. So it's a use case on the other side. So we have run a pen test. No, it's fine. If we go to the Escape security platform, of course, we can see the issues that are populated. So we have a lot of different issues that are accessible in this application. But what do we do with issues? We don't want them to stay here. We want them to be remediated. So fortunately, we have also access to this data inside of Claude Code, and we can just, from the developer standpoint, get access to this data directly in Escape, and it comes with remediation instructions, so we can automate the process of remediation as well. If I click on a specific issue on Escape, right, I have all the information required to perform a full remediation. So it's like a full pen test information and report that you have access to, and you can then use it inside of Claude Code in order to fix the issues. So that's what we will do. Here, I have the source code of our application Duckstore open. So this source code has the vulnerabilities. And what we will do is we will tell Claude Code to go on Escape, search for the issues, import the data, and fix the issues dynamically. I can just say Claude here. Of course, we skip the permissions here because we want it to be fully autonomous. And then I can just use this prompt, right? Send it. And it will find automatically what application it is, find the issues online, and then fix the issues in the code base based on the information provided by Escape. All right. So we have covered 2 use cases already, one for the AppSec team, one for the developers. And now let's take a look at another use case, which is for security engineering. And it's more at scale, and it's more about analyzing the entire attack surface in a single prompt, instead of like focusing on a specific app. So we have run a pen test, then we have used the data in order to provide fixes. But what if we want to analyze the entire company, the entire attack surface, internal and external? So we have this prompt, for instance, that can give us access to the entire attack surface, right? So I can just send it here, and it will also fetch the data from Escape and analyze this. So this one is a bit more long to run because there is a lot of data in the attack surface. We can take a look at it when it has finished here. So this one is an example of the data that you can pull from Escape. So this is a weekly evolution of the attack surface. We can see the new assets that were created this week. We can see the date where the assets were created. We can see per domain what's going on. We have all the data that we need to provide the compliance reports. And all of this is generated without any maintenance. It's automatically captured by Escape. It's automatically sorted out, and then you can access it directly from the AI model. All right. So let's take a look at where we stand here. All right. And we can see that here, what happened is we successfully identified exactly what pen test we are referring to. We downloaded the issues, and then using the data from Escape, but issues were found in the source code, and the model was able to fix the issues properly and gives us a report of the critical severity issues that were fixed. So now, generally, and I will not do it today because it takes a bit of time and we are running out of time, but what you do afterwards is you can just tell Claude, like, okay, I fixed my issues, so run a test again, run a retest, and verify that the issues have been fixed. And Escape will just run a retest and confirm that the issues has been properly fixed and that there are no regressions. All right, so here I showed 3 use cases of like very simple use cases, but yet extremely powerful, of using Escape with Claude Code in order to perform running a pen test, fixing the issues and running a retest, and then analyzing a broader attack surface in a few prompts. But in reality, this can be combined. And especially there is a feature in Escape that unlocks a lot of potential for it, which is the custom rule feature. So the custom rules, they allow to create kind of like retest for specific vulnerabilities that have been found before. And you can create your own. It's not only the agents of Escape that are creating custom rules, but you can also create or import custom rules from bug bounty programs or from any report that you have. And so when you combine all of that together, and here this is a little internal surprise because this is my own type of scripts that I created. I created a command in Claude Code, a custom command for me, which is called the escape tenant review, right? And the escape tenant review command, basically it performs a full analysis of all the data that is in Escape. So it will analyze existing issues, it triage them, remove any issue that is not relevant to us. Then it will perform a more in-depth analysis of all the web applications, all the API services that are discovered by Escape dynamically on my attack surface, find if there are things that are exposed that shouldn't be, classify API services per status. Is it development? Is it prod? Is it protected by a web application firewall? And so on and so forth. And then if there are things that are missed, or if there are obvious issues that are not in my panel yet, it automatically creates the custom rules for Escape, and it automatically uploads the custom rules inside of the Escape platform. So you can basically run it, for instance, once a week, and you have like a full triage, a full analysis of the entire Escape tenant, your entire attack surface, and if there are any misses, you have automatically your custom rules that are added for detection at scale. So this is the kind of process that we are building and that we are working with currently at Escape, and that we see our customers using at scale. All right, I think we are right on time. So this will be the end for me. We'll take some time to answer the questions as well. I'm sure that there are plenty of questions. I saw that Jesse was very active in the chat as well. So thank you for your attention, and excited to answer any questions you might have.
Yes, we do have a lot of questions. Thank you everyone for attending and well, for asking. I think we have, I don't know, more than 20 questions, and indeed we are short on time, so we'll take the most voted one. As I mentioned, like the most voted was about GitHub repo, so no pressure.
I'm working on it. I'm working on it. It'll be there.
I think then the next one is the question to Geet. How do you compare the detection quality with traditional SAST and ASC code scanning?
If Sharon's on, can you explain that in terms of detection quality? Do you mean how good does Claude write the rules? I'm assuming that's the question. So I'm going to go with that. I think it's good, right? The way that I have been running my detection rules in general, right, is figuring out what the rules are and always kind of validating anyway. If you meant the other side, which is like, hey, traditional SAST and IAC, have Claude go over your Git history. Oh, sorry, something different. Yeah, sorry, coming back. I think this is more towards Tristan now that I read this this question, but yeah.
So we on one end we don't analyze the source code, right? Like what we do is we perform analysis from the hacker's point of view on a more on a dynamic side of things. What I can say is that from our perspective on the dynamic side, on the pen testing side, where we see a huge difference in the business logic flows, where the difference is really is if you are focusing on the code or if you are focusing on analysis of the code, the source code, you are missing everything related to the business logic or to what happens when there is actual data or an actual infrastructure running. So it's really a replacement for offensive security rather than for SAST and ISC. On the source code analysis precisely and using LLMs for source code analysis, then it's more, and in combination with traditional SAST tools, Git, that's the topic that you covered today, and I think brilliantly.
Then another question, well, finally from Jesse, who indeed has been very active in the chat. Do you find that it's helpful or unhelpful to fit threat models to the agents?
This is probably for me.
Yes.
I think it's good, right? Like the agents that I spoke about actually create those threat models, right? I think an argument can be made of kind of living threat models, essentially, right? And based on your output, if it's a JSON or whatever your kind of threat modeling output is, I think it's really helpful, right? I think giving the agents a lot of context really helps. A context about your company, your risks, whatever you can, obviously, which falls into kind of your guidelines and AI policy. I think it's only positive, right? The more context it has, maybe it's a business decision about why I gave an example of S3 buckets being public. Why buckets are public, right? If it's a business decision, that's probably in your threat model somewhere. So feed that in, right? I think that really helps in anything investigations, even from the detection side, even from the response side. As much context as you can provide it, I think it's beneficial. But obviously, be careful of, don't provide it like IP, PII, things like that. But as much as you can, the more context, the better, is what I've seen.
And I think we can take the last question, judging by the time, and the rest we'll try to see if we can answer them in writing within the next couple of days from the webinar. So there is a question from Renault who got 3 votes. I've launched AI source code audit on hundreds of repos. It found thousands of issues. Now my challenge is how to forward and follow up all those issues in Markdown to engineering teams. Who wants to take
Do you want to take this? I can take this.
On my end, my advice is don't do that. Start with what's important here is the reachability. I mean, of course, if we launch AI agents everywhere, we'll find thousands of issues. But how many of them? Like, first of all, the false positive rate is an interesting metric because very often, as I was saying, and I don't know if you have seen this Geet as well, but the models tend to exaggerate the severity. They tend to be very frightened by things that are not really security issues. They don't have the full context when they're analyzing the code. Perhaps there are issues, but it's an internal application that is non-connected or doesn't have network access to anything. So of course, you'll find a lot of issues. Our approach at Escape is to start from the point of view of the attacker, specifically to find only what the attackers see, limit the amount of issues, but focus on the ones that are actually exploitable. But that's a start, of course, right? Like you want to start with that. You want to start by doing like the external or kind of like attacker's point of view, and then you want to roll out like the best practices continuously, which is what Geet, I believe, covered in the beginning of the presentation.
Yeah. And sorry, just to add, I think don't do that straight away, right? Like,
yeah.
If an engineering team is not gonna love thousands of or hundreds of findings, as Tristan said, reachability and all that is really good. But even if it's on your side, what I would even do is use that AI audit or Claude and just actually ask it like, hey, you found all these vulnerabilities. Now go back and tell me if, were you just being really cool, or tell me if it actually makes sense, right? And I can guarantee that the thousands will come down.
I think on our side we were already a bit over time from the webinar, so we'll save all of the questions and try to answer some of them in writing. Again, recording will be available on the platform, I think in something like 30-40 minutes from now, if you need to watch certain parts or if you want to kind of screenshot them. You're free. Well, thank you a lot again for joining, and we'll see if I can get also send out to all the attendees the PDF slides of both presenters, so you have that availability as well. Thank you so much.
Thank you, Jill, for joining. Thank you, everyone. Thank you, Alex, for
Thanks, everyone.
Great webinar.
Bye, guys.